Hello everyone, welcome to another CIS tutoring video. My name is Robert, and today we'll be covering the concept and implementation of adding to and subtracting from a linked list. This is the second in a small video series on linked lists, so make sure to watch the first part before continuing this video. Recall that linked lists store a sequence of nodes, where each node contains two parts: data, where the actual value is stored, and a pointer that points to the next node in a sequence. The first node is called the head, which acts as the starting point of the list. If the list is empty, the head is set to null. In this video, we want to learn how to add and subtract nodes in a linked list. We'll explore how to insert and remove nodes from the middle of the list. When adding and subtracting from a linked list, there are two questions you must consider. Is there already a link to the next node, or is it null? Now, let's go through an animation to showcase the insertion and deletion from a linked list. Here, we have a linked list of nodes 1 through 4. We'll first initialize a previous pointer and a current pointer, where previous points to node 2 and current points to node 3. Now, we want to introduce node A to the linked list, inserting it between node 2 and node 3. First, we'll delete the pointer from node 2 to node 3, and reassign node 2's next pointer to node A. Next, we'll assign node A's next pointer to node 3. Lastly, we will assign the previous pointer to node A. And that wraps up our insertion in the linked list. Now, we want to delete node A from the linked list. We'll initialize the previous pointer to point to node 2, and initialize the current pointer to point to node A. First, we want to delete the link from node 2 to node A. We want to reassign that next pointer to point to node 3. From there, we want to delete the link from node A to node 3, now we can safely delete node A. And that wraps up our deletion. Now, let's go over some pseudocode for inserting and deleting a node from the linked list. For inserting, let's create a new node with the new data that the user passed into the insert node function. Then we'll check if the position is equal to 0, meaning they'd like to insert at the head of the linked list. We'll then set new node's next pointer equal to the head of the linked list, and then we'll set the head of the linked list equal to the new node. And finally, we'll return head. Otherwise, if they're inserting at any other point in the linked list, we'll set a previous pointer equal to head. From there, we'll initialize a for loop, looping from 0 to the position the user passed in. If at any point during this traversal that the previous pointer is null, that will indicate that the position is out of bounds and will return head. If the position is not out of bounds, we'll set previous equal to previous next pointer. After the traversal, we will then set new node's next pointer equal to previous next pointer, and we'll set previous next pointer equal to the new node. Finally, we want to return head. For deletion, the first thing we want to do is check if the head is null, which indicates that the list is empty. If it is, we'll simply return head, which returns null. Otherwise, if the position is equal to 0, indicating that we want to delete the head of the linked list, we'll initialize a temporary variable, which is equal to head. We will then set head equal to head's next, and then we will delete temp and return head. Now we want to set a previous pointer equal to head, and then we want to initialize a for loop from 0 to the position that the user specified. If at any point during the traversal that previous is next pointer is null, that indicates that the position's out of bounds and we will return head. We then set previous equal to previous next. We then want to set temp equal to previous next pointer. And then we want to set previous next pointer to previous next next pointer, which means the spot 2 spots in front of previous. We then want to delete temp and return head. In this video, we covered how to add and remove nodes in a linked list, focusing on pointer updates during insertion and deletion. Understanding these operations is key to mastering linked lists. Make sure to practice implementing them in code to reinforce your learning. Stay tuned for more, and happy coding.